In this video, we're going to be looking at something called completing the square. Before we do that, let's just expand some of these brackets. So when you have x plus 4 squared, that means we have the bracket x plus 4 multiplied by x plus 4. And when you expand this, you should get 4 terms. You should get x squared plus 4x plus another 4x and plus 16, which simplifies to x squared plus 8x plus 16. When you expand this one, you end up with x squared plus 10x, because you get 5x and 5x, and then plus 25. This one, you have x squared subtract 6x, since you end up with negative 3x and negative 3x, but then positive 9, because negative 3 times negative 3 is positive 9. And this one here, x squared subtract 14x, and then plus 49. Now, it should be quite easy to spot from looking at these that you can expand them really quickly. So if you look at this first one here with the 4, well, we know they're all going to start with x squared. The 8x comes from doubling the 4. So 2 times 4 is 8, we get 8x. And the 16 comes from multiplying 4 by itself, 4 squared. This rule applies to all of the brackets. So in this one here, the second one, if we double 5, we get 10. In this one here, if we double negative 3, we get negative 6. If we double negative 7, we get negative 14. So you can always get the coefficient of x by doubling the number from the bracket. The end term is always achieved by squaring the number in the bracket. So 4 squared, 16. 5 squared, 25. Negative 3 squared, positive 9. Negative 7 squared, 49. If we keep this in mind when doing the following questions, it will help us. So, here is a quadratic expression, x squared plus 6x minus 2, and we need to write it in this form, x plus b all squared plus c. This form here is the completed square form. Now, the way we do this is we ignore this negative 2 for a second and think, right, how could we get an x squared and a 6x? Well, if we think back to our previous examples, if I had a 4, I got an 8x. If I had a 5, I got a 10x. So if I want to get a 6x, then in my bracket, I need a 3. So this equals x plus 3 all squared. Now if I expanded this, I'd get the x squared that I want. I'd get 3x and 3x, which makes 6x, which I want. But I would also get a positive 9. So what I do is I take away that 9. So this expression here is equivalent to x squared plus 6x. But that isn't exactly what I want. I want x squared plus 6x minus 2. So I just tag this minus 2 on the end. And then I can simplify this to x plus 3 all squared, and then negative 9 subtract 2 is negative 11. It now looks like this form. Now there might well be a negative at the end, but that's not a problem. That just means c is equal to negative 11 here, and b is equal to positive 3. But it should be x plus a number, or x subtract a number, all squared, and then add or subtract a number at the end. This is called the completed square form. Let's have a look at a second example then. So I start with x and something squared, and I want to get negative 10 this time, so I half negative 10, which is negative 5. So this bracket now will give me the x squared I want. It will give me the negative 10x that I want when I square it, double it, sorry, but it will also give me a positive 25 because of the negative 5 squared. So I take away that 25. And I want this 32 on the end as well, so I write plus 32. So these two expressions here are identical, and I then simplify, so I have x subtract 5 all squared, I have negative 25 plus 32, which comes out as a positive 7. So it's now in the completed square form. Here are 3 for you to try, so press pause, have a go at these ones for yourselves, and then when you want the answers, press play and I'll tell you what they were. Okay, this first question then, and you need to go for x plus 4, because that's half of 8, all squared. 4 squared will give you 16, so you take that away, and then you put plus 10. And then negative 16 plus 10 is negative 6. For this next one, we need to do x subtract 3 all squared, since negative 3 is half of negative 6. That gives you a positive 9, so I need to take that off and subtract 1. Which gives me x subtract 3 all squared subtract 10. And the final question, we have x subtract 1 all squared. 1 squared is 1, so I take that off and then keep the negative 15, and I have x minus 1 all squared subtract 16. Okay, let's have a look at a slightly harder example. This time matters are complicated because the coefficient of x is not an even number, it's an odd number. So you might well be thinking, right, well, I can still halve 5, it's 2.5, and then I square that. But squaring 2.5 is quite difficult, and it's much easier for these questions when you have an odd number if you keep things as fractions. So we can simply write half of 5 as 5 over 2. Now when we square 5 over 2, you do 5 over 2 times 5 over 2, which would equal 25 over 4. So that's me now subtracting this number squared. You square the numerator, you square the denominator, and then I still need my plus 10. So this equals x plus 5 over 2 all squared. Subtract 25 over 4. Now the simplifying bit becomes a little complicated because I have a fraction and an integer. The easiest way to do that is to change the integer into a fraction. So I want to have it over 4. That will make my life a lot easier. Now to get 10 over 4 I need to multiply it by 4. So that would be 40 over 4, since 40 divided 4 is 10. This is now much easier to simplify, so I have x plus 5 over 2, and then you can just think negative 25 add 40 gives you 15, so it's plus 15 over 4. There's nothing wrong with leaving these questions as fractions rather than decimals. You can try them as decimals, that's not a problem, but I think you're more likely to make a mistake when squaring numbers with decimals. Okay, here are 3 for you to practice. You'll notice each of these has an odd coefficient of x. Press pause, have a go at these ones for yourselves, press play, and I will tell you what the answers were. Okay, here are the answers then. So for the first one, we have x plus 7 over 2 squared. We subtract 49 over 4 plus 5, which is x plus 7 over 2 squared. Subtract 49 over 4 plus 20 over 4, since that's equivalent to 5. And that comes out as x plus 7 over 2 all squared. Subtract 29 over 4. For this next one, we have x subtract 9 over 2 squared, subtract 81 over 4 plus 6, x subtract 9 over 2 squared, subtract 81 over 4 plus 24 over 4, which equals x subtract 9 over 2 all squared, subtract 57 over 4. And the final question, we have x subtract 3 over 2 all squared, subtract 9 over 4, subtract 4, which is x subtract 3 over 2 all squared, subtract 9 over 4, subtract 16 over 4, which equals x subtract 3 over 2 all squared, subtract 25 over 4. That completes this first video in the series on completing the square.